So yes, good morning, good evening, good afternoon, everyone.
Uh, Jesh, you stopped sharing again, right?
No, I just went into that full screen mode and stopped sharing, I guess. Some minute, I will
Yeah.
start. Yes. Just acting very weird.
You need to share the whole thing. When you click on the share button,
Yes. Uh,
share the screen, not a window. That should
yeah,
help,
I've
Jesh.
shared the screen. This is
There you go. Now I can see it.
yes. So after all the glitches, let's start with this.
Yeah.
So
Don't put it on full screen, otherwise it might go away again. So
yes,
just
yes,
use
yes.
it in
I'm
this
I'm, I'm
window.
keeping
Yeah.
it. I'm
Thank
keeping
you.
it this one. Yes. Cool. So yes, thanks, folks. Good morning, good afternoon, good evening, everyone. So today we'll be talking about doing the right thing, shifting left. And so I'm Jayesh Aive. I'm founding member at Traceable AI, where I run product management for API security. So the AWS machine learning hero. I work on a research projects around distributed neural computers, and on a side thing, I also recently started investing in few of the companies around security and observability space. So if you want to connect with me, you can find me on Twitter at jason_1. I'm happy to have a discussion around security, observability, multi-cloud, all of those things. So we will go through as anything goes, right? We'll go through three things to understand the shifting left security, shift left security. We'll try to understand what, why, and how of shift left. So, what actually is shift left strategy, how it works, how it applies in the security domain, then why you should shift left to start with, and if you are interested, how can you really shift left. So, going to the current state of the world, APIs are eating the world, and every single application, every single modern application which is being built has a distributed architecture, microservice-based architecture, which has which usually has a number of services, and all of these services are running number of APIs. So any modern cloud native application you will see have uh, bare minimum like 1,000, 2,000. Some of the customers we work with even 10,000 APIs, right? And uh, the APIs is the one thing which is considered in the modern world, and it's we have more number of APIs than humans at this moment, really. So as this API first economy is building and evolving, as I said, every organization is trying to build a modern application which is API first, and then CI/CD containers, cloud native tools, DevOps practices which are evolving are really speeding up the software development process. So the speed of delivery has been increasing over the period consistently, but at the same time, the danger in the world, the sophistication of the attacks, then the vulnerabilities, they are also increasing day by day. So we are living in a world where earlier, maybe if you 10 years back, 15 years back, if you want to perform attack on any system, you have to be a security researcher. You needed to know the basic things around security, understand the context, understand the details around it. But these days it's pretty easy for anybody to go on the internet, find out few things, download the hacking tools, uh, download the software which are available out there, and start hacking. So uh, it's not. it's not as straightforward as I'm talking about it, but it's still pretty easier than it was 10-15 years before. So the sophistication of the attacks is not there. The democratization of sophisticated attacks is very big challenge these days. Then security teams and SOCs are already overloaded with bunch of stuff which is going on. There's regular analysis. Then there are new vulnerabilities which are being introduced every day. So security teams are occupied with all those things. And APIs are evolving as a major emerging attack vector, which has a lot of potential and which has it provides you a simplicity. It provides you a very easy way to speed up your software development and even iterations. But at the same time, it's at API granularity, the APIs is emerging as a very big attack vectors. And even as per Gartner, by 2023, most of the security attacks will be API first. So this is a state of the world we live in right now. Then, when we talk about stats, right, only 20% of the organizations following DevOps practices consistently integrate security into the development process. This is a report by HPE. And when we are saying that we should think security first, we should involve security into our day-to-day workflows, day-to-day software development. The stat shows otherwise. Only 20% of the organizations are actually following the integration of a security into the development process. And only 15% of these organizations can actually remediate security vulnerabilities or address the compliance violations as they arise. And I can bet very few of them can actually mitigate the vulnerabilities or resolve the attacks which are happening on them within a day. So it's very hard to keep up with the ever increasing scope of vulnerabilities and attack and compliance violations which are happening. But at the same time, being not able to fix it costs us money as well as the reputation. So a defect that is removed after the product has gone into production will cost you around 100 times more than that which is identified and removed during the requirement phase. So uh, when we are talking about thinking security first and identifying the issue at the requirement phase, we are actually saving so much cost. And again, if something goes into production and customer sees it, or your customer gets impacted because of the particular vulnerability which went into the production, the reputation cost is way more than the money cost which is associated here, right? Then uh, so how what is shift left security, and how shift left will help you to resolve all this thing, or maybe get to a place where your security posture is proactive. So moving security practices left into the software development lifecycle with the goal of shifting from a reactive to a proactive security posture is what we call shift left security. So, in a current state, most of the organizations which have the security teams, which have the which are following the standard practices, many are very reactive when it comes to security. Whenever a breach happens, we go ahead and react to it. We uh, try to solve it. We try to mitigate the issues. Nobody thinks about a security from day zero and takes a proactive measures around it. And even for compliance, in case of compliance for that matter, right, we talk very so this SOC 1, SOC 2 compliant organizations, the compliance has become a checklist where people just go ahead, go through a checklist and see if all the items are checked. If they are, they move forward. But there's no and again, this happens whenever the compliance is due, so it's not very proactive as such. So shifting this whole thing left and proactively analyzing your security posture over the period and trying to resolve issues as soon as they arise in the life cycle, in the development life cycle, is what we call shift left security. So is it as easy as just moving this left part of the window to the sorry, the right part of the window to the left? It's definitely not, right? So there are so many nuances associated with this whole thing. So if you see the traditional security practices, they are very manual and time consuming. So in that there's a security research team in your company which will basically do the pen testing, try different attacks on your application, and all this happens after the developer has pushed the code to the repository or pushed the code which is deployed on a staging maybe, and they're trying it out. They're trying different attacks. They're doing the pen testing, and they come up with a report uh, which again is a very context sensitive, and now developers has to process through that, fix those vulnerabilities again, re-release, deploy on staging, they will test again, and all this thing is very time consuming and very manual. It needs a human intervention every time some new feature is going out or some new product is being built. So developer, and again the second point becomes developers and security have very different domain expertise. So if we see the traditional education or the engineering, even in any course for that matter, right, the security and development doesn't go hand in hand. Whenever you learn about developing a software, most of the people don't think from a security angle, and because and that's not the mistake as well, because both of these are completely different lenses and people have to think from a different perspective to do different things. So in this case the developers have very different skill set, security have a different skill set and different domain expertise, and they both have to work in they can't work in silos, and which is what ends up happening in most of the cases, which is the problem. Then security tooling doesn't surface information in a developer friendly fashion. So most of the security tooling we see provides information in a very security first way, and which can be like attack information or maybe even mitigations, which can be understood very well by people who have security background, like security researchers, practitioners, product security engineers. But the similar information for any developer to process, it's very context, again very context sensitive, and it needs little hand holding to understand and process the information. So again it becomes it takes some time to process, understand and fix the issue as it arises. So it's so definitely it's not as simple as just saying that security is very important and developers have to work that way. So what's the role of developers in security design? So first and foremost is a security first design. Security shouldn't be afterthought at any organization for that matter. So when you are building that, and as I said, that's what ends up happening at most of the organizations. So as you are building the applications, as you are building the features, as we are building uh, as we are building the next set of things in your product, you should think from a security first principles. So if I'm creating the requirements for one product, I'm writing down the requirements for one particular feature I'm building. So we should also try to get the requirements for it clear, the security requirements clear, the security control gets clear, and that way it will be more of a security oriented design than than just writing a code, pushing it, and then security team coming in, raising bunch of issues, and then developers taking weeks or months to fix them. So security shouldn't be afterthought, it should be included in the design phase itself, which will help us solve many issues. And automation is the key, so you can't include involve human in the process every single time you're building the new feature, new product, new commits, or any fix that goes into your product, right? The automation where you can include all of this tooling, you can include all of the tests you're performing, all of the attacks you're performing into a CI/CD pipelines, to different set of automations which exist these days, and the automation makes it very proactive than just going ahead and running things manually after the code gets merged or code gets pushed into the repository. So even so first we started with designing, even in the design phase we're thinking about security principles. Then in the automation we are doing the automation which will which will run the automatic scans or automatic attacks whenever the code is in the development life cycle itself. And theoretical control gates are always your friends, right? Put the right set of control gates. What is the criteria, what are the guidelines, what should come in, what shouldn't. So all this should be sorted out in the very initial stages. And correlation, so this one becomes a major issue whenever somebody asks me about how we think about API security or how we think about application security. To start with, there are three important things we talk about, which is visibility, correlation, and prioritization. So all these are only things that matters when it comes to doing API security, doing application security a right way. Visibility is something which provides you a complete visibility into your application, because you can only protect what you see, or you can only protect what you know about. If there are unknown unknowns in your system, it's very hard to protect those unknown unknowns, because you don't even know if that particular API is being hit or not, that particular API is being called or not. So how can you go ahead and protect to start with? So visibility is the key. You get the list of all the entities like API, services, backends in your system. Discover that. The discovery becomes a very important part. Then the second thing is correlation. And why correlation? Many modern organizations end up using bunch of tools for different use cases. Like for SaaS, there's Sneak. For maybe DAS, there's Stackhawk. For RAS, there's Traceable. There's Contrast. There are a bunch of other tools. And all this information from a different security perspectives, from different angles of security, like static application security testing, uh, then your dynamic application security testing, active security testing, even your 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 traditional WAF, your traditional RASP. All this information which is there is in silos right now. These are different set of tools which are providing different set of informations, and your security team is basically trying to correlate all of this and provide you a concise report. So there should be tools you're using which correlate all this information, which provides you a concise dashboard, uh, and which helps in prioritization, which was the third point I was talking about. So once you get all this at the one place, you get a single pane of view into your security ecosystem. You can prioritize things better and mitigate them as early as possible. And the fifth is use developer learnings to better protect the production. Developers are the people who are writing this code, who know most about the things that are going into your system. So you should always leverage developer learnings to better protect your product, which you are deploying into the production. So yes, those are the five things. And most of the modern tooling which is available, and most of the modern set of applications which are building should be built in this way, should so we are able to identify all the problems uh, at the left side of the cycle, where we are actually building the code, or actually writing the code, pushing the code, putting it to staging. Every commit should be analyzed in a way for all the attacks, which can be all the vulnerabilities which can be exploited in your application. So we're talking about the three phases: this build, ship, and run. And there are different things you do at a different stage, and there are different tools associated. The list can go on. I have just put a few of them here. So at the left side of a thing, there's a vulnerability management, which I was talking about, the correlation, the visibility and the correlation part of it. So you uh, when you're getting vulnerabilities from the different source, like DAST, SAST, IAST, uh, active testing, all of the sources are providing you different set of vulnerabilities. And you should be able to correlate all this. You should be able to get a single pane of view into all of this and prioritize things better, prioritize what matters, and mitigate what matters to start with. Then for compliance, we have open source tools like OPA, which can be used to set the policies, and again put the control gates wherever possible. Then access control, you have Fortify, you have a bunch of other tools. For cloud native security, again the CSPM side of things, there are many tools available. For the runtime, there's Contrast, No Name, Traceable, bunch of other tools available. Again, runtime becomes more of a right side of things, but when you go from left to right, build, ship, and run, There are different phases and different toolings you have to use at different levels. So yes, that is actually all from my end. It was a short presentation. So yes, you can read. If you have any questions, feel free to reach out to me and jayesh@traceable.ai. Can reach out to me on Twitter as well at jayesh_away. And yes, so thank you for joining in and do the right thing. Shift left, and that is all about keeping the eye open, right? It will help you protect in a very early stage of development life cycle, and keep you away from different set of attacks. Cool. So yes, that is all from my end. I'm gonna give you like 30 minutes. If you have any questions, please feel free to ask them. Happy to answer.
Yeah, guys, if you have any questions, please feel free to ask. If the session is over, I'm gonna stop the recording now, Jayesh.